In this question we have to evaluate 15 plus 20 plus 25 all the way up to 535 without actually going on adding them all up. Okay, so this is an AP because you can see you're adding 5 each time here. So we know that the first term is equal to 15 and the common difference is simply 20. Take away 15, which is 5. Now the formula we'll need to use here is the nth term formula, because we'll need to work out how many terms we've got, so we look at the last term to work that one out. So we use Tn equals A plus n minus 1 d. So that becomes 535 equals the first term, which is 15, plus n minus 1 times the 5. Subtract this from here, we get 520 equals 5 into n minus 1. Divide that, 5 into 520, we're going to get 104 equals n minus 1. So n is 105 terms altogether. Now, we have to use the sum to n terms formula here, and there's two ways we can do this. We could use this formula, Sn equals n over 2 into 2a plus n minus 1 d. We could use that one. Or what we could do is here, we could just change that slightly, write as n over 2 into a plus n minus 1 d. You'll notice here that is the nth term, which is actually the last term. So often we replace that with L. So they're the two formulas. Now we can only use this particular formula if we know what this term is, which we do. So this is the one we'll use. And we'll see that the sum, and it will be summed to 105 terms, is equal to n over 2, which is going to be the 105 over 2 into the first term, which was the 15, plus the last term, which is 535. And that comes out to 28875, I believe. I didn't do that in my head. Okay, 28875. Right, done. Right, into question 2. How many terms of 45 plus 47 plus 49, etc. give a sum of 1365? Now we can see this is an AP which is going up by 2. So we can say the first term A is equal to 45 and the common difference D is equal to just 2. Now this time I'll use the sum to n terms formula this way. It says Sn equals n over 2 into 2a plus n minus 1 d. Alright, now we know what the sum is, it's this number here. So what I'll do, I'll write down 1365 equals n we don't know over 2 into 2 times a is 90 plus n minus 1 times 2. And we notice there's a common factor here of 2 in here, so I'll just take that 2 and get rid of it. So we're going to get 1365 equals n into 45 plus n minus 1. So this becomes, over here, we'll do it this way, that's going to be n to, now n, this will be n, and this will be 44, that's plus 44, and that's going to be equal to 1365. Removing the brackets, we get n squared plus 44n, and we'll bring this across to the other side. We're going to get minus 1365 equals 0. Now I'm not going to try and work out the numbers that are multiplied to give me minus 1365 now to give me 44. I just use the quadratic formula. So we'll see that n is equal to minus 44 plus or minus the square root of 44 squared minus 4 times 1 times the c, which is the minus 1365. And that's all at 2. That becomes minus 44 plus or minus square root of, I don't know what that is. It would be something. Bring out the old trusty calculator. And that will give me, when I do work all that out, it's minus 44 plus or minus, I think it was, 86 all over 2. Now, obviously, you're not going to take the negative ones because you can't have a negative n. So the answer is n is equal to 21. So there were 21 terms needed to get a sum of 1365. Done.